Okay, let's continue our discussion. In this video, I'm going to speak about a new operator. We name it a delta operator, and I'm going to show you how we can derive Euler-Lagrange equations using delta operator instead of, let's say, epsilon eta method. In this method, which is which used more than epsilon eta method, we are going to find variation of the function. We define a variation of the function, and using the first variation of the functional, we can find equations of differential equations of the system to extremum a functional problem. Let's start our problem. First of all, we define delta operator. Delta operator is a name which is given to a certain variation in a definite function. Let's say y is a definite function, y is a known function. We know the value of y of x. For example, y of x is the solution of the functional problem, and y tilde of x is the set of all acceptable functions which with a small arbitrary change with respect to y. So the difference between y tilde and y is delta of y. So delta of y of x can be said as a small arbitrary change in the dependent variable y. Okay, I highlight it here, so you can read it here. A small arbitrary change in the dependent variable. In the dependent variable, I emphasize on the word dependent variable because we know that independent variable does not have any variation. When we use delta operator, we just only have variation in the dependent variable. If we go back to our previous slides, let's say here we define y tilde as y plus epsilon multiplied by eta of x, where epsilon is very small number and eta is a differentiable function, and y tilde is our set of functions which can pass through 2 points, which pass through 2 points x1 and y1 and x2 and y2, or y tilde of x is a set of function which satisfies boundary conditions of the problem. Let's go back to our definition. So as we said, delta y of x is equals to epsilon multiplied by eta of x, and delta y must have be chosen in the way that boundary conditions of the problem will be satisfied by this function. I'm going to discuss about the boundary conditions of the problem in our next sessions in more details. But in this session, I especially want you to be familiar with this concept, variational operator or delta operator. Okay, till now we know that what is delta y of x, and in graphical view we can say that delta y of x is a vertical displacement of y of x, and we don't have any change in the independent parameter x, and there is a distinct difference between d of y and delta y, as we can see here. When we define derivative of the function, we say that d of y is the vertical displacement of y when we have a small amount of change in an independent variable d of x, while when we say delta y, the value of x is fixed, and we only change the value of y with a small arbitrary amount. This is the main and definition of the delta operator. With this definition, we are going to find the solution for the variational problem. Let's go to our next slide. In the delta operator has some important properties. For example, the first important property of the delta operator is that the variation of the derivative of the function is equals to derivative of the variation of the function. We can prove it very easily. Delta of d of y over d of x can be written as we said in our formula is d of y tilde over dx minus d of y over dx. If we factor the term d over dx, we have d over dx of y tilde minus y, and this term is equals to delta y. So we can easily say that the delta operator is commutative with the differential operator. In the similar way, we can show that integral of y tilde d of x is a varied function for integral of y dx, so we can conclude that the variation operator is a commutative with integral operator, or we can say that the variation of integral of the function is equals to integral of the variation of the function. These two main properties are very essential, and we will use these two properties frequently in our next slides and our next sessions. However, before continuing our discussion, let's speak about something important, I want to speak about using the variation of the general function and oh, I'm sorry, let's tell it again. We are going to speak about calculating the variation of an arbitrary function. Let me show you some of my notes. As you can see here, I want to calculate the variation of y dash by 2's. By definition, I can easily say that the variation of y dash by 2's is equals to y tilde dash by 2's minus y dash by 2. So if I replace y tilde dash as y prime y dash plus delta y dash, all of them by 2 minus y dash by 2, and expand this term and do some simplification, I will have this term. As you can see here, our final result, or the amount of delta y dash by 2 can be calculated by this formula. You can see here it's equals to 2y dash multiplied by delta y dash plus delta y dash by 2. If, as we told previously, if we assume that delta y is a very small change, so we can say that delta y is an order 1 and delta y2 is an order 2 parameter, which can be neglected for small values of delta y. This term can be neglected in comparison with this term, and in other words, we can say that the first variations, or the variations of order 1, the first variations or the variations of order 1 of the function y dash by 2 is equal to 2y dash multiplied by delta y dash. This is very important formula. Now let's speak about another example. I'm going to calculate the delta operator of y multiplied by y dash. By the definition, I can say that this term is equals to y tilde multiplied by y tilde dash minus y multiplied by y dash. We replace y tilde and y tilde dash by these two terms and expand this equation to some simplifications. We can easily see that this equation is equals to delta y multiplied by y dash plus y multiplied by delta y dash plus delta y multiplied by delta y dash. In this example, similar to previous example, if I neglect second order terms or higher order terms, the first order terms are these two terms, or the first variation of y dash is equals to delta y multiplied by y dash plus y multiplied by delta y dash. In the general formula, we can say that if a general function f is function of x, our independent variable, y, where y is function of x and y dash, and so on, we can say that the first variation of f is equals to partial derivative of f with respect to y multiplied by delta y plus partial derivative of f with respect to y dash multiplied by delta y dash, and so on. If we have y double dash here, we have partial derivative of f with respect to y double dash multiplied by delta y double dash, and so on. Let's calculate some examples. For example, let's say f is equals to sine of y plus 2y y double dash. I want to calculate the first variation of this function. Okay, using the above formula, we have y, we don't have y dash and y double dash. So we can easily say that the first variation of f is equals to partial derivative of f with respect to y multiplied by delta y and partial derivative of y with respect to y double dash multiplied by delta y double dash. I do similar here. You can see partial derivative of f with respect to y is equals to cosine of y, plus 2y double dash, all of them multiplied by delta y, and partial derivative of this equation with respect to y double dash is equals to 2y multiplied by delta y double dash. Now let's solve another example. Let me show you here. Let's continue. Okay, I think you can now see it here. We have f is equals to y dash by 2 plus 2y y dash plus y by 2. Okay, if I want to calculate the first variation of let me write here. If I want to calculate the first variation of f, I can easily show that the first variation of f is equals to partial derivative of f with respect to y dash multiplied by delta y dash. We can say that it's equals to 2y dash plus 2y multiplied by delta y dash, and partial derivative of f with respect to y multiplied by delta y. Partial derivative of this equation with respect to y is equals to 2y dash plus 2y multiplied by delta y. Okay, this is enough for now. Till now, so we can calculate the first variation of any arbitrary function f. For example, if f is an arbitrary function of y, x, y, and y dash, we can easily say that using Taylor series, the first variation of f with respect to y can be calculated by this formula. the first variation of f with respect to y is equals to partial derivative of f with respect to y multiplied by delta y plus partial derivative of f with respect to y dash multiplied by delta y dash. It's enough for now. In the next session, I'm going to use this formula to find Euler-Lagrange equations using delta operator method, and how to find, moreover, how to find boundary conditions using variational approach or delta operator method. It's enough for now, and I hope to see you soon. Bye bye for